Alright, in 6.5 they talk about the most useful formula, amortization. This is where you borrow money, take on debt, and you make regular payments to pay off that debt. So this is when you want to buy something now, but you don't have the money. So you finance it. You use a credit card, car loan, house loan, boat loan, plane loan, anything where you're borrowing money from a bank or a financial institution or putting it on a credit card. Whatever it is, this is amortization, this formula here. Now the tricky part of this amortization formula is right here. You got the negative exponent in the denominator. In the past we had negative exponents, but at least they were in the numerator. That made it a little easier. Now, this one's tricky because a lot of students will calculate this guy, and then they'll say this minus 1, which is wrong. And then they'll get this, what they think they got, and then they divide it by that, and that's all backwards. Okay, you have to calculate what this guy is, and then I recommend you write that number down, whatever this guy is. And then you take this over this minus that, or just do it in 2 steps. This minus your number, and then whatever I is divided by that number. And then finally times A, and that gets you your R. But you got to be careful here. It's so easy to type in this guy, figure it out, and then subtract 1, and then divide by I. That's the exact wrong thing. That's the opposite of what you want to do. Alright, so for 6.5 you want to be very careful here. Alright, 6.5 number 3. They give you a debt of 80,000 or 8,000. It's amortized in 8 equal payments over 4 years semi-annually at 12%. So 12% semi-annually, so 0.06. Semi-annually 2 for 4 years, that's 8. And so you plug in everything that you know, and you got to crunch this down very carefully. Figure out what 1.06 to the negative 8 is, and then 1 minus that, figure out what that is, and then 0.06 divided by that. So again, if you figure out what this is, okay, and then the next line down say 1 subtract, and then do second enter. It will call up, it'll type in on that line ANS, but that's the number that you just calculated, and that's what you want there. 1 minus ANS, and you hit enter, and you get the denominator, and then hit 0.06 divide second enter, again ANS, answer, and it'll give you what this whole thing is. Okay, and then multiply it by 8,000. And you get this number here. So semi-annual payments of this much for 4 years will get you $8,000. Or will kill off an $8,000 loan. 5. You have 18,000 in loans at 4.2% compounded quarterly for 10 years. So 0.042 over 4. 4 times 10. And you plug in everything that you know. And again, you want to do this very carefully. You might even want to do this bottom step in one step. 1 subtract 1.0105 hat negative 40. Figure out what that is, and then 0.0105 divided by that, and then times 18,000. And you get your answer there. Number 7, they're remodeling their kitchen. They can afford a $600 payment. How much can they borrow over 5 years? At 6% monthly. 0.06 over 12. 12 times 5. Plug in everything they know and divide by 600 or by 0.01933 something, and it says they can borrow 31,000 over 5 years to fix their kitchen. Number 9, develop an amortization schedule for the loan described. $100,000 for 3 years at 9% compounded annually. Okay, so your payment number is 0, 1, 2, and 3. Payment amount, interest, and so on. So you calculate with what A is and I and N are. You can calculate what R is. So now your payments are these 3. Okay, and the interest that is accrued on this is 9% of 100,000, which is 9,000. Okay, and the balance reduction is the difference between these two, 30,000 something. And then what's left of 100,000 from this is your 69,000 that's left. So the total interest you paid is 9,000. You make another payment, and how much interest did you pay? Well, it's the interest on this at 9%. Well, you pay 6,000 something, less than the previous time. So you take the difference between those two, and that's your balance reduction. Subtract that from this, and you get this guy. So what's your total interest? These two. So now you make your third payment. What's the interest? It's your unpaid balance times 9%. Take the difference between these two to get you the balance reduction. Unpaid balance is now 0. Total interest is all three of those. So here's your total interest. Here's how much you paid, or how much you killed off, 100,000. How much you actually paid is 118,000. So you paid extra, an extra 18,000 to be able to have the right to borrow 100,000. 11, same idea. You're borrowing 20,000 for 1 year at 12% compounded quarterly. Okay, 0.12 over 4, 4 times 1. Okay, so it gives you all these numbers, and so your regular payment is 5380.54. That's how much you pay each time. You start out with 20,000 at 12%, so you figure out what 12% of that is, and it's $600. The difference between those is this guy, and you subtract it from your unpaid balance, and that's how much you now owe. Oh, what's your interest? It's right there, 600. So now you make another payment. I calculated the payment down here, so that's how much I know you're paying each time. The interest is your unpaid balance times 12%. It's this guy. The difference between those two gives you the balance reduction. The difference between those two gives you your balance that's unpaid. What's your total interest? Those two added together. You do it all again, and again this guy times 0.12. Difference between those two is this one, and then you subtract and you get this guy. Total interest is those three. You do it again. Difference is this guy. You finally paid off everything, and the interest is all of these guys added together. So you ended up paying 21,500 something, and your interest was 1,500 something, and you paid off 220,000. So you ended up paying $1,500 in interest. Number 15 says she bought a car 2.5 years ago. She borrowed 28,000 for 48 months at 8.1%, compounded monthly. Okay, her monthly payments are $684.88. She'd like to pay it off early. How much will she owe just after her payments at the 2.5 year mark? So 2.5 years is 30 payments. So you do this whole thing 30 times. Takes a while. Okay. Number 17. Man buys a house for $350,000. He makes $150,000 down payment, so he's really only borrowing $200,000. Semi-annual payments at 12% for 10 years. So 0.06 and 20 for your numbers. Crunch everything down, and you got quarterly payments of $17,400. Okay, so that's the size of each payment. B says what's the total amount paid for the purchase? Well, that's your monthly payments, or your payments times the number of payments, 20, plus the $150,000 down payment. That's how much you paid. And C, total interest paid over the life of the loan. Well, this is how much you paid, and this is how much you bought it for. So the difference is you ended up paying $148,000 in interest, about half the value of the house. Okay, number 20. He purchased $10,000 worth of equipment, made a $2,000 down payment, so he only borrowed $8,000. Semi-annual payments at 10% for 4 years. So you plug in everything that you know, and his payments are $1,237.77. And how much did he actually pay? 8 payments of that plus the original down payment. What's the interest? The difference between that and the $10,000 that you wanted to value the item. And 30, a young couple buys their first home. They borrow $85,000 for 30 years, monthly at 7.2%. Okay. After 3 years, they're able to make a one-time payment of $2,000 along with their 36th payment. Find the unpaid balance immediately after they pay the extra $2,000 and their 36th payment. So they paid $576.97 each month for 36 payments. So multiply that times 36. And then you add another $2,000 on top of that. So you've got 576.97 times 36 minus 2,000 or plus 2,000. And what they come up with here, they said the unpaid balance is 80,000. And no, that can't be right. I'm going to come back with the answer. Hold on. All right, let's look at question 30 again. They're borrowing $85,000 for 30 years, compounded monthly, so 12 times 30 is 360. 7.2% divided by 12 is 0.006. You end up getting a payment of $576.97 every month. So then they ask, what's the unpaid balance immediately after their 36th payment and paying an extra $2,000? So you take the $85,000, multiply it by 0.006, and you get the interest. But when you multiply it by 1.006, you get the original amount plus the interest. That's how much accrues at the very first month. You subtract the payment, and you get this guy. Then you do it with that guy times 1.006, and you subtract another payment. You get this guy. And then you do this again with each successive one. You continually multiply by 0.006 and subtract 576.97. You do that 36 times, and then also subtract another 2,000, and you get $80,317.87. Now, Part B says, how many payments of that will amortize the unpaid balance from Part A? So you got to figure out what time is, how many years, because you know how much you need to pay off, you know how much you're paying, you know your interest rates and all that. So you divide by 80, or you write this over 1, and this times that gives you the top 2 times that gives you that, and you still have the bottom. Cross multiply and you get this guy. Divide by 576 and you get this. Subtract 1 and you get this. Divide by -1 and you get this. Now you're ready to write it as a log. Log base 1.006 of this number equals -12t. So you get this negative number equals -12t, or this positive number equals positive 12t. Divide by 12 and you get this. That's how many years. Multiply by 12 and that's how many payments. 301.04 payments. Okay, so part C says how much will the remaining debt be after the full payments are paid? So you'd have just 0.4 4/10 of a payment left, which is $230.79. And that's how much you'd have to pay on the extra on the very last payment to pay it all off. Part D says how much will the couple pay over the time of the loan, so that's that times that plus 2,000 gives you that. And then if they paid the original loan without the 2,000, they'd end up paying $207,000 instead of $196,000. So how much should they save by paying that extra 2,000? Well, $11,039.52.